Good morning. I have entitled this talk, Blockchain, a Broad View. And I want to tell you, I am thrilled to be here. I'm thrilled to be the senior advisor to Pandora, and I hope this week of blockchain in Shanghai will be very exciting, and I'm sorry that I can't be in Shanghai to be with you. So we live in an era that is unprecedented in 5,000 to 7,000 years. 5,000 or 7,000 years ago, people began to move into cities. And before that, they had lived in the countryside, they had lived in the forests, they had lived in nature. For the first time, people began to live in things constructed by people, to be constantly influenced by decisions that people had made about the structure of the place they lived. Now we're doing it again, and we are moving our civilization into digital media, which means that many things that were merely facts of life are now matters of public and technical policy. Now, the program here is in a sense very straightforward. We are trying to develop equivalents of each of the traditional brick and mortar business and production practices that we have. The great success of communication. Within my working lifetime, largely within the last 25 years, the internet has come to connect everybody in the world. But we have a lot of work to go on in developing our business practices for this new environment, and in particular, in respect to accounting. And that's will be the large focus of what we're looking at today. So there's a tremendous paradox in our thinking. People are fond of saying, if food was free, or if land were free, there wouldn't be any wars. But the minute they get something that's free, like digital data, they struggle to try to figure out how to make it scarce, because what they know about is an economy of scarcity, in which you charge things from people because there isn't an abundance. And that applies particularly with respect to sort of intermediary commodities, money in particular. Looking at blockchain accounting, looking at blockchain technology, you say, what are its functions? Well, the essential one is to distribute accounting, and I'm going to describe a little bit about how that's done. Make the relationships among the data structures both visible, make them verifiable, and also to make them immutable. So we have something that serves as an economy and a commodity of exchange. Now, in some sense, those things aren't new. We've been doing those things, but we've done them by centralization. And so there are record depositories, census bureaus, patent offices. We have things that need to be coordinated. You appoint a coordinator, and that organization keeps records and connects them. Very important among these are central banks, and touching everybody's lives are credit card systems. Unfortunately, there are problems with the pre-blockchain solution. One is scalability. Something that works fine for a small town, or maybe even for a substantial city, has lots of trouble when it's extended to all of China or all of the world. They concentrate authority, which is a mixed blessing. You make one authority concentrated. Authority typically likes to be concentrated. On the other hand, then you create something which is subverted or attacked or corrupted, can be very dangerous to you. And this leads us on to the question of reliability and security. We need to build a mechanism that is not going to fail us. So, we're in a world where things that were once beyond human control, like the gold supply. Oh, humans controlled it a little, they went and explored and found gold and mined it and so forth. But over a given day or a given year, the amount of gold available to people didn't change much. And in fact, say in the 19th century, it was so stable that for a lot of that period, the U.S. set the value of the dollar at $20 per ounce of gold. That's about a little less than $1 a gram. That stayed stable for decades, and then in the 1970s it was decontrolled and became another commodity because it had in effect been supplanted by the central bank system, which has the great advantage of adding tremendous elasticity to money, produced what are called fiat currencies. So what we're looking for now is something that at every moment represents the consensus of the people to what the situation is. And so we have to ask, what do we do? One of our great successes in this program of moving our culture and our business into digital media is the digital signature. A digital signature is a transformation of data that only one person can do, but many people can see was done correctly. One person can sign, many people can verify. So in the past, we have done signatures. The three ways I know that are most common are the written signature, or the stamped ink signature, or in some very fancy documents, the stamped wax signature. And now all those things depended on physical artifacts. Now we have one that is purely digital in form. Now, associated with that is, incidentally, we have solved another problem. And turns out by some similar techniques. And the other problem is, we live in a world where you can now have, you probably have Facebook friends all over China. You can't necessarily afford to go visit them, but you're very close to them, you talk to them all the time. And the question is, in the past, until decades ago, the basic mechanism of a private conversation was the two of you walk off a few feet from other people and you chat. And now that doesn't exist in the digital world. And it is replaced by the use of encryption for this purpose. So you need a mechanism for arranging a private conversation with somebody you never physically meet and with whom you talk on and off at different places over great distances. And that is called public key negotiation. Well, I've said these things are great successes, and they are. But they also have a great difficulty. They depend on secrets. I sign something by using a secret key that only I know. And you can verify it using a public key that you look up in the telephone book. And therefore, if something happens, if my secret key gets out, then other people would be able to sign my signature. So whenever you have a secret of any kind, you have a vulnerability because the secret might leak. So blockchain turns on a whole new approach to signing things. And we're going to look at that in several steps. The first element in that is something, maybe the very simplest of cryptographic phenomena, doesn't depend on a key, is called a secure hash function, or I prefer the term message digest. It creates a little tiny thing, a few hundred bits, that is inseparable from a large thing, could be terabytes. And these functions are easy to compute. You want them to be very fast to compute. You want to compute them on gigabytes of data, at least megabytes frequently. They're very, very hard to invert. If you know one of these message digests, it's hopeless to try to find a message that has that digest, even though you know there are huge numbers of them somewhere off in the cloud, so to speak. And it's very hard even to find two items with the same hash, even if you don't care what the hash is. There are three very important standard message digests. Sort of the historical one is called MD5, the fifth one to come out of a very productive and influential cryptographer named Ron Rivest. The other two are both national standards. Something called SHA-2, Secure Hash Algorithm 2, is the US standard, and we'll mention it again in a moment. And SM3, Commercial Cipher 3, is the Chinese standard. 45 years ago, a man named Ralph Merkle saw how to apply these things to a signing phenomenon that's very different from the kind of digital signatures I was mentioning. Merkle built what's called a Merkle tree. And everywhere you see two little items coming together on that tree, or that the item below is a message digest of the two above. And the result is to create something that is very tamper resistant. So once you have a tree of this kind, and you know that root that's down at the bottom, the widest of those blotches, then you can't be fooled about what one of the documents is. Somebody says, this document is in this tree, you do a bunch of calculating, and if that root isn't what you expected it to be, you say, no, that document isn't in that tree. And there are no secrets involved. So you manage to create a rigid data structure that acts like a signature on each of those documents that depends only on knowing a small amount of information, and that makes it very tamper resistant. Now that was carried a step further in the 1990s. And people think that's Stuart Haber on the left and Ariane Lenstra on the right. And they developed something called Lenstra and Haber timestamp. What they do is people submit documents that they want timestamped. Now you've invented something, you want to establish a priority. You get a timestamp on a description of your invention. And so people from all over send them things and get back timestamps. This was carried a step further by two people named Ariane Lenstra and Stuart Haber in the 1990s. They built Merkle trees of document hashes as a way of attaching times to documents, what's called timestamping. So you've invented something. You wanted to apply for a patent, and you want to establish your priority when you invented it. And so you send it in. Actually, you send in a hash of it. You don't have to disclose it. And you get a timestamp on that hash showing that you knew that hash on the 5th of March. And you can't, there's no way you can come up with that thing later. And then over the course of a week, they would develop one of these Merkle trees, and every week they would publish the root node of that Merkle tree in the New York Times, what Noam Chomsky calls the newspaper of record of the United States. Now, blockchains are a way of doing that same thing, but eliminating the physical element of the newspaper. So this weekly publication of the root of the tree is replaced by a constant discussion among the people who participate in this system as to what the root is. And they changed the name a little. The root's called the block. So every few minutes or every few hours or every few seconds, this group get together and manufacture a new block. and these blocks are chained together. So the whole thing is about producing a very public, a system that does not depend on secrets, but a system that is very rigid, very tamper resistant. Can't change it. Once it's sat down, you can't change anything about it. Which means it's a reliable source of history. You can go back and study it and discover what things happened. This is applied in several ways, of which the one that became explosively famous initially was an attempt to make a new form of money, and that was called Bitcoin. And other people have been trying that since, and has mixed results. The next thing that caught everybody's attention is supply chain management. Because unlike inventories and accounting within one company, supply chain, people come, people go, you're in a rush to get things, you find a new supplier. And so you need a multi-company distributed database of what these things are. And in general, this gives you a mechanism for trustworthy distributed accounting. So, the history of the attempt to make money is very straightforward. We once had immutable commodities like gold. It wasn't the only one, but it's the most famous one. And that was tamper resistant. It was very rare that anybody could increase the supply of gold very much, or decrease it very much. But it had that was an advantage, that was a disadvantage, right? You want to start a great new business, you need lots of money. Well, if money is gold, you need lots of gold, and maybe there isn't that much. So that gave way to what are called fiat currencies, which were it was central banks of nation states that put forth currencies and stood by currencies. One of the most important little bits in the Constitution of the United States is that it would assume the debts of its predecessor and continuity in accounting. And this added tremendous elasticity to money. The elasticity becomes a function of public policy rather than a fact about how much gold there is. Now, the objectives in doing this were threefold, and you might not share the objectives. People wanted to be transnational, the way gold was. Wanted to be inflation resistant. That's a very interesting idea that's basically gone nowhere. And they wanted it to be totally digital. And that has been a success. But the results, Bitcoin has failed as a currency. As a commodity, it's incredibly volatile. It was about $62,000 a coin this morning. And it can drop 10%, it can drop 20%, it can rise. That's not what you want in money. And in light of that, right, it's meaningless to talk about inflation resistance in something that moves around. In a day it can move more than inflation moves in a year. Supply chain management has, in some sense, I don't know if this is widespread yet, but it doesn't have any of those same problems. It does have the problem that it isn't easily centralized. And it rescales rapidly. If you have a tremendous business success, all of a sudden your supply chains become much longer and much bushier, and everything has to be redone. If you have a scalable mechanism like a blockchain, then this can address that problem. So basically, where do we stand? We have a tremendously promising new technology. It is, depending on how you reckon, 12 or 13 years old, or maybe a little bit, maybe it dates back into the 90s. And it's just barely begun to be explored. So I'll close as I opened with Xi Jinping. He said, we must manage blockchain while holding our course of keeping the internet under the rule of law and pushing forward the ordered development of blockchain. Well, I wish him luck. Great new developments don't always have ordered development.